All right, let's have a look at this question here. This is from the Theta Mathematics, and this is 24.02. Of course, it's question 16. It says there are a choice of five. Oh, sorry, this is a probability question, by the way. So there are a choice of 5 airlines for the Auckland Honolulu route. The 5 airlines are, they just call it A, B, C, D, E. These airlines have respectively 5, 7, 9, 1, and 3 flights per week. So let's write that down here. So you've got airline A, B, C, D, and E. I'm tempted here to draw a probability tree, but I don't think we need to for this. The airlines respectively have 5. What's this one? 7, 9, 1, and 3 flights. So this is the airline. I'll put airline. These is flights per week. Put per week. And it says records kept last year to evaluate the on-time performance show that the proportions of late arrivals for each airline are 20, 30, 40, 50, 25, respectively. So this one here is 20% late, 30% late, crikey, 40% late. Oh my goodness. This one's 50% late. Don't take this one. And this one's 25% late. All right. Okay. Says, what's the probability that a randomly chosen flight on this route will be late? Well, what we want to do is just kind of average them out, really. So the probability that this one will be late is going to be 0.2 times 5. So this is going to be the probability of late. I put P late equals. So this is going to be 0.2 times 5. This is going to be 0.3 times 7. This is going to be 0.4 times 9, 0.5 times 1, which is just 0.5. This is 0.25 times 3. So you could really just do this on a calculator, really, but most of the time you don't actually have to. Or 2 5s are 10, so there's going to be 1.0 if you like. 3 7s are 21, so this is going to be 2.1. This is 4 9s are 36, or 3.6. This is going to be 0.5, just nothing's changed. And this is 25 times 3, well, it's going to be 0.75. So let's add all of those up, and I just can't be bothered doing it in my head. So let's make sure we've got what we're meant to be having here. Sorry, I'm just moving this around so I can actually see it. Is that a focus? Go back and focus. What do you got to do to focus on these days? Focus. Oh, look at that. Needs to be in focus in order to see this, yeah, folks? Sorry about that. Okay, so we've got, and I'll just type this in here. We've got, 0.25, oh, sorry, we've got a 1. I'll just add this up. We've got a 1, a 2.1, 3.6, a 0.5, and we've got a 0.75 as well. Let's make sure we've got the right number there. 1, 2, 3, 4, 5. Yeah, looks good. 7.95. I got that right? 2.1, 3.6.5. Yeah. Okay, it looks about right. So I've got 7.95. So the total late. So total late is equal to 7.95. But 7.95 out of what? How many flights are there altogether? Well, you've got 5 and 7 is 12, 21. Got 25 flights. So the late proportion of late, so you've got late is 7.95 over the total flights. Flights is 25. So 7.95 out of 25, what is that? 7.95 out of 25 is 0.318 equals 0.318. So the probability, we say, of random flight, I put random chosen flight being late is 0.318. Now, notice, by the way, I'm using point. Typically in statistics, when you've got things like p-values, when the leading number cannot be greater than 1, can be 1 or less, we generally don't use a leading 0. You can, of course, and some things do, but in a lot of the professional, especially if you look in the published statistical reports, we just use a point. In other words, the 0 is superfluous, the 0 is redundant, it's extraneous, it is not something that we need to have in there. So I would say the answer there is 0.318, and that's my answer.